Okay, welcome ladies and gentlemen. We're following up on the periodic table that we have been researching and organizing and understanding and all that sort of stuff. Valence electrons and energy levels and all that good stuff. And we're going to introduce Bohr models and Lewis models, Lewis dot diagrams. Bohr models you saw in your card, your element card research. But Lewis dot diagrams are a bit different. So let's start with the periodic table. First thing we need to know is that the organization of the periodic table is important. It's meaningful. Mendeleev was not the only one to develop a periodic table, but his had the most predicting power. How he put them together allowed scientists to leave gaps, see gaps, to look for future elements, because the periodic table arrangement's meaningful. It's based on the atomic number, not on mass. Now, the original periodic tables, the early ones, were based on atomic mass because they didn't have the mechanisms to identify all the isotopes and that sort of thing. And also, it's based on the behavior of the atoms, of the elements. And that's something that Mendeleev saw that others didn't see, based on the behavior. And the behavior is because of the valence electrons. An atom behaves the way it is because of the valence electrons and what they want. Oxygen is so disruptive to iron, to other things. It allows things to burn, for example, because of its valence electrons. Neon behaves the way it does because of its valence electrons. And valence electrons are the outermost electrons. So the valence electrons are the electrons on the outer energy level. Now, when you're filling in your energy levels, you have to fill the first before you can go on to the next one. And just a couple of rules. The first level holds 2 electrons, E negative for electron, and the others hold 8. And you can't start the next one until the first one is full, etc. Now this holds true for our 26 elements that we researched. Once you get into the bigger ones, when you have more electrons, you talk about energy shells and S and P's and whatever. We're not going to do those. We'll get to those later. So we use the Bohr model in class as a way of talking about those energy levels and the valence electrons. So if I have magnesium is atomic number 12, which means it has 12 electrons. So 2 in the first, 8 in the second. And that takes care of the first 10 electrons. So I'm down to 4 more. And then I need one more energy level to hold the last 2 electrons. And that's my Bohr model. The Lewis dot diagrams cut to the chase. Lewis dot diagrams say, it's wonderful knowing all of the inner energy levels, but they're boring. It's either 2 or it's 8, and it's boring. So Lewis dot diagrams say, let's just show the electrons that have the meaning as far as behavior. So magnesium has 2 valence electrons. Let's just show those 2 valence electrons. And that's the Lewis dot diagram for magnesium. Much simpler, but it shows the relevant information. So magnesium, I know it has 2 electrons in its valence electron because it's in the second column, it's in the second group. If I go to neon is in the far column. It's a noble gas. It has 10 electrons. So it has 2 less than magnesium. Magnesium has 12 electrons, neon has 10 electrons. So neon has 8 electrons in its outer energy level. Remember, 10 electrons, 2 in the first, 8 in this outer energy level. Nitrogen has, nitrogen, there it is, no it isn't. Oh, I'm looking at its N, sorry. Nitrogen, just plain old N, there we go. Nitrogen has 7 electrons, so 2 in the first means that there are 5 in its outer energy level. So that would be a Lewis dot diagram for nitrogen. Now these valence electrons determine behavior because these elements have a goal. These elements want something specific out of life. The goal of all atoms, of all elements, is to have a full outer ring. They all envy the noble gases. A full outer energy level. They want to be like neon. They want to have all 4 sides, 2 electrons, nice and pretty. And they go to some extremes to that. So they want to have a full outer energy level, like the noble gases. Now the noble gases are inert. They don't react. They don't do anything because they're already happy. The other electrons want to be happy like that, but they can't. So in order to be happy, they have to form bonds. So the bonding between electrons help those atoms to have full outer energy levels. There's 2 ways that they can do that. 2 different types of bonds. Running out of space. There's ionic bonds and covalent bonds. So the goal of the atoms here is to have a full outer energy level. 2 kinds of bonds. The first one is ionic bonds. And we're going to spend most of our time with ionic bonds. Ionic bonds is giving or taking electrons. Giving or taking electrons. So magnesium, with its 2 little outer electrons, says, here, you can have them, take them, and then I can drop down to a full energy level. I have too many, take them, get rid of them. Where nitrogen, with 5 of the 8 that needs to be full, will say, give me 3, I want 3. And so they form bonds so that they can get rid of electrons and take electrons so that they can be full. And the other kind is covalent bonds. We're going to run out of time probably before we talk about covalent bonds, but they're nicer. They're all about sharing electrons. You can have it for some time, I'll have it for some time, so we'll share it. They'll go around both of us. It'll be great. And I suppose there's a third kind too, which we're not going to talk about hardly at all, but metallic bonds. How do metals get together? Tomorrow in class, you're going to get the From Bohr to Lewis model worksheet, and you're going to be given a list of elements. You're going to draw the Bohr models and the Lewis dot diagrams. Have a good day.